Okay, what we're going to talk about today is solving geometry problems. Now, we've done a number of different things talking about different kinds of angles and those sorts of things. What we want to do is put that into some practice. Now, when we talk about geometry problems, what makes them sometimes slightly more complicated than what we have already been doing is that they will often take 2 steps to solve. So let's use this example. Now you might look at that and say, well, that looks pretty hard. I don't really have any idea how to do that problem because I want to know how big that angle right there is. But with the knowledge that you've already learned, you can do that. We have 2 parallel lines here. And so because of that, we know that 2 angles are the same, which I'm going to talk about in just a second. But one of the keys to solving geometry problems is to just start writing down what you know. So, here we go. We have 2 parallel lines. We know that this angle and this angle are corresponding angles, right? We have 2 parallel lines and a transversal. So that means these 2 are corresponding angles. And if the lines are parallel, then that means that these 2 corresponding angles must be the same. 65 degrees there. We also know that a straight angle adds up to what? To 180 degrees. So what do we have here? We have a straight angle, or we have 3 angles together that add up to 180 degrees. We know that this is a right angle, that's what the square means, so this must be 90 degrees. And those 3 angles together must add up to 180. So if I take these 2 angles and add them together, 90 plus 65 gives me 155. Those 2 and that must add up to 180. So if I say 180 minus the 155 that I have here, I subtract, borrow, and I get 5 and 2, which means that this angle, A, is equal to 25 degrees. That's how geometry problems work. Let's try a couple more examples to see if you can start to get the gist of what we're doing here. Now notice again we have 2 parallel lines, and they're cut by a transversal. Sometimes you have to extend these lines in your mind to see that we have 2 parallel lines here, and we have a transversal that goes that way. Okay? And then we also have a right angle here that's 90 degrees. And we have a rule that we say that the angles in a point add up to 360 degrees. So right here, we have a point, and we have 3 angles there that we know must add up to 360 degrees. This is a right angle, it has a square, so that must be 90 degrees. And we know those 3 must add up to 360. So we add these 2 together, 170 plus 90 gives me 260. And then I subtract that, 360 minus 260 is 100 degrees. So that must mean that this angle inside here is 100 degrees. And because we have parallel lines, we know that these 2 angles, and what are they called? They're called corresponding angles, just like these 2 up here. Those 2 corresponding angles must be equal. So if this is 100 degrees, then that must be, and we know that B is equal to 100. Here's another problem. Same sort of an idea. Notice again we have some parallel lines involved and so on. But what we have that's a little different here is, what do we have? We have 2 parallel lines, and you can think of those lines as extended. And we have a transversal that cuts this way. Do we have corresponding angles we're dealing with? No, we don't. But what we do have is in co-interior angles inside the parallel lines and on the same side of the transversal. And if you don't see that quite, consider this angle, which is 70, and this angle over here, the whole angle, which is 60, and then C. We don't know how big C is yet. But what we do know is that this angle plus this angle is equal to 180 degrees. So we could write it like this: 70 plus this angle, which is 60 plus C, is equal to 180 degrees. Now, we know from the associative law that if everything over here is addition, that it doesn't matter where the brackets are, so we can just get rid of those brackets for now. And we can say 70 plus 60 is 130, plus C is equal to 180. So what I need is some number that when I add it to 130 is equal to 180. Well, how would you do that? You'd subtract, right? You would take that 130 away from 180, and we would find out that C must be 50 degrees. And that is how you solve geometry problems.